Hello. S and space to see that it surely gives done at the end when it's done. Welcome back to Python Challenge for All. Okay, so let's continue our AI solution to 8 puzzles. So last time we tried greedy search, which is kind of try prioritize the seemingly best solution, which has the estimated least cost to the goal, and do the work. But actually, it was not very good. Always not. It's not optimal. It gives some suboptimal answers. So the homework was to another estimation, which is a total Manhattan distance to each desired location. Okay, so let's continue. So the idea is, I think it's clear, but for example, if given this, yeah, as I said, 7, for example, this one, 7 should go to where? Here, right? So the distance is 2. 2 is correct, so distance is 0. 4 should go here. 1, 2, 3, 4. So our distance is 1, 2, 3, like that. Okay, 6 is in correct position 0. 1 should go here. So it's like 1, 2, 3, 4, and like that. So it can be done by um, yeah, let's continue. So today's work, we're going to make a star search. So let's save and okay, let's quickly do the work. Okay, so instead of hval here, maybe we can try very similar hval2, which is yeah, instead of 1, mdist to say I and the correct position, the current position, and stat I minus 1. This is the correct position. So this is all. And we can delete this. Okay. So the distance, the h2 evaluation function is if that panel is 0, it will be 0, but else it will be Manhattan distance to the correct position of that panel for all points. Okay, so let's try this and quickly see how it looks like. So run it. It will be like this. So S, done, 30 steps. Great. But I don't think it's the best way. Anyway, it works. So I think this is somewhat good enough. Sn. S. Okay, seems fine. Okay, let's make the fix n to 0, so it can solve all problems. If I check fix n to 0, yeah, everything is free. So in this case, let's try S. Oh, 30 steps, great. N, S, 44 steps. So 44, if you remember, um, all 8 puzzles can be solved in at most 30 steps. So this is not optimal. Anyway, it solves the problem. It's interesting. Yeah, maybe this is not good enough, but anyway, it can solve it. Interesting. So today we are going to solve in a very wise way. Okay, done. Okay, fine. Okay, so let's go to today's work. Yeah, so we tried this last time, and we now try this one, H2, which is a total Manhattan distance to each desired location. Okay, so today's topic is A star search. Oh, really good name, A star, A asterisk, A star. So what is it like? So it borrows from two different approaches and combined them. From uniform search, we found that we should prefer paths shorter from the path start. Okay. Uh, so in uniform search, we used G function, which is basically the distance from the start node, the length of the path so far. Okay. And then also from the greedy search, we found that the heuristics gives estimated closeness to the goal. So the ESTA search idea is use both of them. Use the sum of past cost and estimated future cost. Okay? Past cost is G and estimated future cost is H. And use the sum as the estimated goodness. And sort using Fn, which is estimated total cost of path through n to goal from start. Okay, so let me show this slide. Okay, so here we try to expand the search area, and so in the uniform cost search, we used this value g, which is the length of the path from start to current position. Okay, GB. And then in greedy search, we estimated the expected estimated cost from there to the goal. And in A star search, we add both of them to calculate f of A is like g of A plus h of A equal 13. And f of B equals g of B plus h of B equals 11. So in this case, we try B first before exploring A. We prefer this one rather than this. So by sorting all the nodes in the open list, which has the least value of F value. Okay, let's implement this. So here, let's save as A star search. So it will be lesson 84, A star, 8 puzzle. Okay. So just simple. Here, eval_stat, we already have H value, which is H2 value. And so we'll add G value as well. Okay. So maybe in eval_stat, we give stat only the current state. But instead of that, okay, here, instead of that, we should give the path, not. Oh, okay. Oh, okay. Just this will do. So instead of touching eval_stat, we can just use here. Okay, uncomment this. And we already have gval, which is length of the past path, and hval, which is the estimated cost from there. So we will use, instead of hval, we use gval. Okay. Let's write this way for clarity. Hval. No, fval. Fval equal gval plus hval. And use fval as the estimation function and sort according whichever fval which the least f-val path. Okay, a path with the smallest f-val. Okay, this is all. And let's try this with a new one. And you can compare it with the case where we don't use g-val or not. Okay, let's run this. Okay, here, for example, let's try S. Ooh, it's taking time. Okay, good. It gives 24 steps. Okay, as you can see, it's, I will, if you're interested, you can find out that this is optimal. Okay, 20 steps, done. Very good. Okay, so now this is actually, you can try yourself many problems or do more quantitative comparison of several approaches, several algorithms so far I have explained. So for example, give a set of the same problem sets and compare the number of trials before solution and the length of the path to see if it's optimal or not. Okay, this was very simple, but this is the idea of A-star search. And I will explain, this is a very good algorithm. You can solve, so far as I know, it can solve any 8 puzzles in reasonable time. Okay, so I hope you will try yourself many cases. H-val is this, H2, and G, compute G, H, and then F, which is a sum of G plus H. And use F-val as the sorting key to find the path which has the minimum F-val. Okay, um, and then this function will sort open L before popping up the first element, which is the smallest F value. Okay, I hope you will come back next time. You will try yourself many problems and come back next time for further exploration of sliding puzzles. Oh, before closing, maybe I noticed something. Here, the goal state is tuple, and the last line here is comparing, here in the draw function, comparing it with self.board. So it should be whichever. Maybe we can change this to list of goal state. So it can print done when it's done. Okay, S and space, space, space to see that it surely gives done at the end when it's done. Okay, fine. Okay, I think this is good enough. I'm sure you like it and try many things as you like. And be sure to come back next time. Bye bye.